All right, good morning, everyone. My name is Nagesh Battula. This is the Ask Tom Office Hours session on Oracle Sharding, which is a brand new Oracle database feature that has been released as part of 12.2 last year. Right. So what we will do is today we're going to do a short overview of this particular feature, and then we'll spend a lot of time at the end for question and answers. If you have any, we can discuss that as well. Once again, I said, my name is Nagesh. So I've been with Oracle for almost 6 years now. I've been the product manager for global data services, as well as Oracle Sharding. Prior to joining Oracle, I was a regular customer like yourself, worked at Intel and other companies, but primarily working on Oracle high availability technologies. Okay. So what we'll talk about today from the agenda perspective, we'll introduce you to Oracle Sharding. We will take a look at, what does it take for you to deploy a sharded database, and how do you create a sharded schema? And then once you create the sharded schema, how do you do routing from your clients to the right shard so that you can execute your transactions, right? And we'll talk about other lifecycle aspects of a sharded database, and we'll touch upon the benchmark results of the scalability study that we have done on Oracle Cloud. I'm going to showcase those results. And we'll take a look at the competitive aspects at the end, right? I do have customers' slides, customer success stories. In the interest of time, I may not be able to cover that today, but I certainly would include in this deck so you can take a look at it. So now, what is Oracle Sharding? It's basically a geo-distributed multi-model Oracle database. Okay. In its simplest form, a sharded database involves horizontal partitioning of data across a pool of Oracle databases. Okay, so let's say in this example, I have one large database, and it has numerous partitions, regular table partitions. Right? When you shard the database, what you're essentially doing is basically you're distributing these partitions across a pool of databases. In this example, partitions A, B, C, D on shard 1, E, F, G, H on shard 2, so on and so forth. So you're distributing your partitions, and of course they're replicated for high availability. I'm not showing that aspect in this picture. So now I said they are distributed across multiple shards. Shards are nothing but regular Oracle databases, right? But the important thing is these shards run on separate servers. This could be physical servers, or this could be VMs, or this could be Exadata for that matter. But there is no shared storage that binds these shards together. Okay? And there's no clusterware that binds these shards together. In essence, it's a loosely coupled system built on shared nothing hardware architecture platform. Okay? Now, how do one distribute your data or partition your data across these shards? Right? We do have multiple mechanisms, multiple sharding methods that we support. In its simplest form, it's consistent hash-based, so you get linear scalability. We also support composite sharding, wherein you can assign some set of shards for one geographic location, some set of shards in another geographic location. And within each geo, you could still have linear scalability using consistent hash. Okay? Those are the two methods, consistent hash-based as well as composite sharding. And in AT&C, we're also introducing list-based and range-based sharding as well. Okay? So this is at a high level what sharding is, right? Now, as a customer, why would I be interested in sharding? The first benefit is linear scalability. For my current business requirements for this particular application, I could start with few shards. Okay? Let's say in this example, I have 10 shards. And that's good enough for my scalability requirements, my database size, and my number of concurrent users, etc. Right? But if my business is doing great, my application needs to support more users, larger database, and more transactions, all I would do is add more shards to this pool, right? And I would get linear scalability. So basically, it's elastic in that aspect, right? So you add shards, you automatically rebalance data, and you get linear scalability. And you would add online fashion. There's no downtime that you would take to add and incrementally scale your database. That's number one. Number two is extreme availability. If you step back and see today in a single database architecture, in a non-sharded database architecture, all your data is in one gigantic database. And if that database undergoes a service or switchover or a failover to a data guard instance, right, all the users undergo a brownout during that role change or role transition. Okay? But because in the sharded database, your data is distributed across multiple shards, let's say one of the shards is undergoing a failover or a switchover, the 9 other shards are completely unaffected. They are supporting your business and the applications are running. Only this one particular shard where you have 1/10 of your data is undergoing a drama. So it's available in a different way. It's not 0 or 1, it's a non-binary one. Okay. The third one is geographic distribution. This is important for a global customer where you want to store European data in European data center or Asian data in Asian data center. That's one use case. The other use case is you want to bring your data closer to your users, the data proximity aspect. We support that as well with Shard. Okay? So in summary, basically linear scalability, extreme availability, and geographic distribution are the 3 key benefits in addition to many others. Okay? Now, what I'm going to do in this slide is quickly touch upon the components of a sharded database, and we'll talk about what are the key features of it. Okay? So if you look at the diagram here, at the bottommost tier, I have database here, which is the shard tier. I have a bunch of shards where the data is distributed as well as replicated within these shards. Okay? And I'll talk about how replication is done in the next couple of slides. Okay? Now that's the shard tier. And at the top, you have the application tier. Okay, in the application tier, you pass a sharding key using the APIs that we created, that we provide, and I'll show how the examples on those as well. You pass a key, and then that's how you check out a connection from the pool. And the connection pools are smart enough to get you routed to the right shard so that you could execute your transactions. And I'll talk also about how connection pools have that intelligence to understand the shard topology so that they can check out the connection in the right shard. Okay, we're going to cover that as part of the routing section. So you have data tier, you have the connection pool tier, and then in the middle, what you have is the shard management and routing tier. Okay, there are 2 components in the shard management tier. One is the shard catalog, the other one is shard director. Shard catalog, think of this as a regular Oracle database that persists the metadata of your sharded database, right? What the shards that you have, where they're located, what's the replication technology you're using. All that information is persisted in the catalog. In addition to the metadata, shard catalog also hosts the goal schema of your application. So let's say your application has charted tables, duplicated tables, etc. Those are the actual DDL is kept in the catalog in a dictionary table, right? Later on, the shard directors, in conjunction with the catalog, will make sure that those DDLs are propagated to all the shards, right? So your goal schema is kept in the catalog. In addition to the goal schema, shard catalog also assumes the role of a proxy router. We'll talk about what a proxy router is when we cover the routing aspects. Okay? So that's catalog. And shard directors, as I said, they're instrumental in the routing and management aspect. So for the DDL propagation, shard directors play a big role. And also they publish the notification to the connection pools, whether it's a runtime load balancing metrics or whether it's the service failover metrics, right? All that real-time events are published by shard directors to the connection pools. That's how connection pools know in real time, which shard to connect to, etc. So they're instrumental in the routing and the management team. Okay, now let's talk about the features. I said there are up to 1,000 shards in the first release, right? The creation of the shards and the replication is completely automated. You have declarative syntax that will show the examples that you specify, hey, here are my shards, here are my nodes that you want to create the shards on, here are the regions that you want to create the shards. You specify it with the declarative syntax, and the framework automatically builds the sharded database with the replication included, whether it's data guard or golden gate. Okay. Like I said, multiple sharding methods, consistent hashing, composite, and in the 18C you have you have the range and the list-based sharding. Centralized schema maintenance. The beauty of sharded database is you're not following a proprietary interface, right? You're not adopting a proprietary interface here. It's regular SQL, ANSI SQL that has been enhanced in support of a distributed environment. So it's if you're an Oracle database, the transition to a sharded database is very, very easy because it's all native SQL syntax, right? And I'll show examples of how sharded tables are created using SQL syntax and duplicate tables as well. But they're all created from one central location, which is catalog, right? So you manage your schema from one location. You don't have to go to each and every shard to add tables or modify tables. So routing, right? We talked about the deployment, we talked about the schema aspect, and then now the routing, right? The data is distributed. Now, how does the client know which shard to go to, right? So we have two ways of doing it: direct routing and proxy routing. Direct routing is what you're going to use when you want to achieve massive linear scalability, right? So as part of direct routing, you specify a key. A key could be account ID, email ID, right? Customer ID, etc. You pass the value of the key. And then as you pass it using the APIs that we provide, connection pools will allow you to get to the right shard, which has the data pertinent to that particular key. Once you connect to the shard, you execute all your transactions within the scope of that shard, like a regular Oracle database. You could do insert, update, delete, whatever the case may be on that particular shard for that particular key. Once that's done, you check in the connection, you're done, right? And that's very fast and scalable, right? So that's direct routing. Proxy routing is one when you cannot pass a sharding key as part of your connection checkout. Right? There will be some modules, some workload that in your application that you can't pass a key for one reason. The second reason is maybe you intentionally don't want to pass a key because you want to do aggregations. Maybe you're running reports, right? Then you need to go to multiple shards, right? Let's say you're doing sales aggregations, etc. And then you need to go to all the shards to get to that data. Then you do what's called as proxy routing. Proxy routing happens by connecting to the catalog. Catalog's other name is also a coordinator, proxy route. So you connect to the catalog and you execute a SQL unchanged as is. You're going to run your massive SQL query on this catalog. And the catalog, as I said, acts as a coordinator. It parses the SQL, decomposes it, pushes the SQL down to the shards. Queries get executed at the shard level, and then the data is brought back. And then if there's any ordering or sorting that needs to happen, it'll happen one last time and send back to the client. Right? The advantage of proxy routing is this. You don't have to write ETL routines to move data from a sharded database to another data warehouse and run your SQL queries there. You could leverage this sharded infrastructure by taking advantage of this coordinator and run your SQLs to generate your reports. Right? So direct routing is what you're going to use for your OLTP transactions. Proxy routing is what you're going to use for your reports, etc. I also talked about the online scale out. So for incremental scalability, you simply add shards and you get linear scalability. You can also scale in. If you have allocated too many shards, maybe if you want to relinquish some, you can take them off as well. Sharding is supported both for on-prem as well as the cloud. Right? You could even have a hybrid deployment, some shards in the cloud, some shards in the on-prem as well. And then the sharding framework gives you full support for the lifecycle, whether it's if you want to rebalance, you can explicitly do a rebalance. Or if your chunk of data is too big, you can split a chunk. Right? All those aspects are natively supported by sharded database. We'll talk about those later. Now, I talked about replication for high availability. Okay, let's talk about this. The default high availability is data guard. So for each and every shard, you have, as part of the default deployment, we enable data guard with faster failover. Right? So if a shard is down, we automatically fail over to its standby. Okay? That's data guard. We also support golden gate. So in this example, I have 3 shards. I have a chunk of data shown in different colors. Like in this case, Gray, I have the chunk is in shard 2 and its copy is in shard 3. Likewise, red is in shard 3 and its copy is in shard 1, so on and so forth, right? So and then we automatically enable chunk level active-active replication using Golden Gate with auto CDR, the conflict detection and resolution. Okay? So if a shard goes down, no big deal. We have these copies of the chunks on the other shards, and we automatically route you to those copies. Right? So within these 3 shards, you have high availability baked in for your data. So your data is available within these 3 shards. Versus in Data Guard, you need to have a dedicated standby for each shard. Okay? And some customers were expressed interest in enabling rack at the shard level. So in this example, I have a 2-node rack cluster for each shard. Okay? So we could, if you want to have that additional node level scalability and availability at the shard, you have that opportunity with using rack along with shard. Okay. Any questions so far? Okay. So we talked about the concepts, the advantages, etc. Right now, let's talk about how do I create a sharded database. I mentioned that there is some declarative syntax that we've created that you can leverage to deploy sharded database. Okay. So now, in this example, I'm showing few commands that will allow you to deploy sharded database. Again, my intention is not to bore you with the syntax and all these parameters, but allow you to appreciate how simple it is to specify your topology and make one command called deploy which does the automation for the creation of the sharded database. So you say create shard catalog. That means you're building this catalog and you specify which database that you want this catalog to be on, etc. And then you say add GSM. GSM is nothing but a global service manager. The marketing name for that is shard director, right? So behind the scenes, it's the GSM listener that is being created that acts as a shard director. Okay. For all you care, it's a regular Oracle listener that's been beefed up, that's been empowered for a distributed environment. Right? So you create a pool of GSMs. In this example, I have 2, but you could have up to 5 GSMs in each region, 5 shard directors in each region. Right? So you define your GSMs and you specify a listener ports. And later on in your application connectivity, you're going to use these listeners instead of your scan listeners, instead of your database listeners. You're going to use these shard directors, listener endpoints in the TLS states. After the GSMs are created, you specify the credentials of your Oracle OS user and password. Okay, and then you create these logical groupings: a shard group 1, and then shard group 2. So shard group 1 is a set of shards that are deployed as primary. And shard group 2 could be a set of shards deployed as standbys. You're just specifying, hey, these shards in this group are to be deployed as primary, and these shards in this shard group are deployed as standbys, right? During the deployment phase. And then you say add invited node, you're registering these servers with the catalog. And then you say create shard, right? You're basically here, you're specifying, hey, I want a shard that should belong to the shard group 1. That means it should be deployed as a primary. And here is the host that you want to create the shard on, and then you specify credentials. What you did until now with these steps is basically you're specifying a topology. You specified the default, in this case is data guard. You specified the host using the create shard command, right? And then created the shard group, the logical grouping, etc. And then once this specification is done, you run the deploy command. All of these are done in an interface called GDS-CTL. Command line utility. You can also do this with Enterprise Manager as well. Right? So you run the deploy, which does the automation of creation of the shard databases, setting up the replication, and if it's data guard, it'll set up the broker with the password failover, with the observer enable. Right? The whole 9 yards is completely automated. You just specify what shards I'm going to have and what replication technology that I'm going to use. Right? After the database are created, I would say add service. I'm going to create a global service. In this example, OLTP read-write service, role primary. That means I'm going to run this service on all the shards whose current role is primary. right? And this is the service I'm going to use it in my TNS names along with the shard director listener endpoints. Okay. Now,
Nagesh?
yes.
Quick interruption. We've got a question from Max. I assume I need standard Oracle licenses for each node in the sharding configuration. What other licenses will I need?
Absolutely, absolutely. Good question. So sharding is included as part of your Active Data Guard or Golden Gate or Oracle RAC. So as long as you have one of these high availability options, sharding is covered. The other important thing is these have to be enterprise edition databases, right? So it's EE plus one of the high availability options, either Active Data Guard or Oracle RAC or Golden Gate. There is no additional separate license for sharding. Okay, so now we talked about the deployment. Now the next important thing is the data modeling and application constraints. Sharding is very, very close to the application developers. So in the non-sharded database, DBAs drive it, right? The creation of the database, the setting up, the whole 9 yards is done by the DBAs. With sharding, yes, DBAs do all the good stuff of deploying the database, etc. But once the deployment is done, there is a handshake that needs to happen with the application developers as well as architects, right? That drives the success of an application on a sharded database. And we'll talk about what those are, right? To get the best scalability for a sharded database, there are certain application design and data modeling constraints. So what are those? First thing is the application should be shard-amenable, right? So two aspects to that. One is that certain tables must be nominated as a sharded table family, and certain tables are nominated as duplicate tables. Okay, so let me talk about what those are. So in this example, I have a schema which has customers as a parent, and then at the root as well as the child, orders, and line items, grandchild table, and I have a products table. Okay, so the important thing is these tables, the customers, orders, and line items, must be equipartitionable. Okay, that means if my sharding key is customer ID in this one, I need to have customer ID in the orders as well as the customer ID in the line items as well. I'll show you an example of how it would look too. Okay, and the reason why they need to be equipartitionable is so that we can store related data together. That means a set of customers, their orders, and their line items, those related partitions are always kept in one and only one shard. Right? The advantage being, if an application comes in with a certain key, let's say Mary's customer ID, you will be rest assured that you're going to go only to one and only one shard to get Mary's profile information, Mary's orders, Mary's line items, all within the scope of one shard, because we have equipartition and stored the related partitions in a given shard. Right? And that's our scalability mantra. You want to have co-locate related data, right? So that when you do joins and integrated constraints checks, you're always doing within the scope of one shard. So you're not globally doing these checks. That will be, an inhibitor to linear scalability. Okay.
Nagesh, another question from Max.
Sure.
Does that include referenced partition tables, or does the key have to be physically present in each table?
Right. So the key has to be present in each table. That is the requirement. At least in this first release, we expect that key to be there in all the child tables, and then you would call out the reference partitioning. Okay. And this will be very apparent when I show you the syntax of how you create a root table and child table, and I'll walk you through that too. The other important thing is, for that given application, for their requirements of that application, you need to identify the best sharding method. Would it be consistent hash? Would it be composite? Or would it be list or range, where the list of keys are mapped to a shard or a range of keys are mapped to the shard? It all depends on the application requirements and what's the right sharding method, right? And what's the right sharding key. That need to be closed during the design time, right? Once you design it and then deploy sharded database with this particular method and this particular key, it's not easy to change it unless you rebuild your sharded database. So it's an important aspect that needs to be closed with the application developer. What's the method? What's the key? And the sharding key must be the leading column of the primary key. Right? Most of the cases, the primary key is the sharding key. But if it's not, the sharding key has to be the leading column of the primary key. Okay? And for tables that you cannot place a sharding key, let's say in this example, I can't place a customer ID in the products table. What we will allow you to do is there is a mechanism with which you can duplicate this particular products table at all the shards, right? So the products table, let's say you have all the list of all the products and that information. That particular table is duplicated on all the shards so that in your transactions, if you're joining customer tables, orders, line items, and products, again, you're joining within the scope of one shard. Right? Your transactions are not doing distributed transactions. Okay? And typically, these products are, they're not read-write kind of a use case. It's read mostly type. Right? You load it periodically, let's say once in a day or once in a while, and then you want that particular data to be duplicated on all the shards. Okay? So those are the data modeling considerations that we expect. Now, here is that example that I said, how I'm going to create the sharded tables as a duplicated tables and duplicate tables. I take the same example, customers, orders, and line items. I have some sample data here, Mary, John, and Peter color-coded. And then I have Mary's orders in red, John in orange, etc. Now, when I shard them, I want to co-locate them, right? So I had to make sure Mary's orders, line items, and her profile information is always kept within one shard. I'm showing one record example. I could have millions and billions of records, right? So basically what I'm doing here is I'm co-located related data together. Likewise, John, his orders and line items are stored in shard 2. Peter in shard 2, so on and so forth, right? And what about my products, the duplicated table? We make the copies of them on all the shards using read-only materialized views. Every 30 seconds, this data, which is this products table, which is created on the catalog database, is synchronized on all the shards using read-only materialized views. Okay, so now Mary comes in, she will be routed to this particular shard 1, and when she performs transactions, all her data is within this one shard. Okay? That's how you get to linear scalability. You could have millions and billions of customers. At the max, for each customer, you would only go to one shard. Okay. So before I show the syntax, there is one important concept that I want to touch upon, and this is very critical for a sharded database. There is a concept called chunk. Chunk, in its simplest form, is a table space. In its simplest form is a table space that contains related partitions of tables. So partition P1 of customers, partition P1 of orders, partition P1 of line items. Those 3 partitions are placed in one table space, and that table space is called a chunk. Okay. Now, a DBA can create these 3 partitions on 3 different table spaces as well. In that case, those 3 table spaces, the table space that's hosting customers P1, the table space that's hosting orders P1, and the table space that's hosting line items P1, those 3 table spaces are logically mapped to what's called as one chunk. Okay? So in some simplest form, a chunk is nothing but a table space. But in cases like this, where you want to have separate table spaces for separate partitions, those 3 table spaces are mapped to a chunk. Chunk is our unit of data movement. For example, when I add shards, we rebalance. Now, how do we rebalance? We move data at the level of this chunk. Right? So a chunk is moved from one shard to the other as part of rebalancing. So when you move it, you can again be rest assured that the related data is always kept in that chunk, and you're moving them at the level of the chunk. Right? You're not in a state where you're going to leave this customer P1 in shard 1, orders P1 in shard 3, etc. Not in that state. You're always keeping them together. Right? So chunk is our unit of data movement, which plays a big role as part of rebalancing when you add shards or remove shards, etc. Okay. Now, there is another interesting one that I need to explain. It's called table space set. When you create let's say you step back, and in a non-sharded database, when you create a partition table, as a DBA, what I would do is, for my create a partition table, I list out my columns, my data types, and I specify my partitioning strategy, right? Whether it's list or range or hash, etc. And then I list out my partitions, partition B1, 2, 3, 4, etc. And then I map a table space to each partition, typically for good practice. We map a table space for each partition, right? And we take the same exact notion here as well into the sharded database. But then in a sharded database, you will have thousands and tens of thousands of partitions, right? So now how would a DBA go and create these 10,000 table spaces? So what we did is we automated that. So with one command called create table space set, a DBA gets to create numerous table spaces. And what's the number? So in this example, I have shard 1, 2, and 3. The default number of table spaces, the default number of chunks per shard is 120. That's the default that we have set. 120 table spaces in shard 1, 120 in shard 2, 120 in shard 3. So altogether, over these 3 shards, we create 360 table spaces, right, with just one command. Okay, so the prerequisite is done. The table space creation is done. Now I would go into the creation of a sharded table. So I did the create table space set as a DBA. I'm done. I have 360 table spaces. So now I go use the new syntax called create sharded table customers. And if you look at it, the syntax is very similar to what you've been used to in a partition table. Your columns, data types, constraints, etc., and you define your primary key. But this time around, for this strategy, you say partition by, you say consistent hash. This is the algorithm that we use for you to get linear scalability over the distributed environment. And the sharding key, which is the customer ID. Okay. And then I also specify the table space set, which is nothing but the one that I just covered in the previous slide, which is the 360 table spaces. Right? The last thing I also note is the partitions auto. I'm telling the system, hey, create 360 partitions. I already have 360 table spaces. Create 360 partitions. Map each partition to the table space. Right? So that complete definition of a sharded table across the shards is completely automated using the simple syntax. Right? Something that you always have been used to, except for a few clauses called sharded table and the algorithm for consistent hashing. So this is my root table. What about my child table? In this example, I'm showing the orders. As I mentioned, I need to have my customer ID that needs to be quote unquote denormalized for this particular application design. I have customer ID in my child table, and I have primary key and the foreign key that refers to the customer. And I say partition by reference. Right? What I'm doing here is exactly the equipartitioning. If I have 360 partitions here, I will have 360 partitions in the orders table. And that's how we know what are and these partitions are created on exactly the same customer ID. 360 partitions based on customer ID, 360 partitions based on customer ID here as well. And that's how we know what partitions are need to be co-located and placed in a given chunk. Right? So, and like when you have line items table, it follows the exact same scenario, uses partition by reference there as well. Okay. So to answer your question that you posed, Max, yes, you need to have customer ID that needs to be denormalized. Basically, the order needs to be denormalized with the customer ID, and also you would use partition by reference so that we can co-locate related data. And what about my child table? Right, we have a syntax for that as well. Create duplicated table. When I do this particular, when I execute this particular syntax, I'm going to create this table on the catalog. Right, that's where I load my data, and then every 30 seconds, the read-only materialized views will get refreshed on all the shards. Right, so the data would be updated on the shards. Okay, I'll stop here. I know we talked about quite a bit on this. I want to see if there's any questions I can answer. If there's no question, I'll move on. So the other important thing that will come to somebody's mind is, hey, do you have a single point of failure anywhere in the sharded database? Let's talk about that. I mentioned shard group 1, shard group 2, right? One set for primaries, one set for standbys. And if something goes down, we automatically fail over at the shard level, not at the group level, right? If this particular shard goes down, I fail over to this. It's standby, right? So over a period of time, I could have some set of shards primary in shard group 1, some set of shards standbys in shard group 2, etc. But the important thing is you have high availability for your data. Whether it's data guard or golden gate, you're protected. Shard catalog needs to be protected with an active data guard standby, right? So you have protection for that as well. And then shard director, you want to have a pool of shard directors in each region, right? I'm showing 2. You could have at the bare minimum 1, 2 for high availability, and the best practice is to have 3, so that your connections. So this basically you have a pool of shard directors that are doing the routing as well as the management of your sharded database. So you have high availability as well as scalability baked in using the pool. Okay? And then of course you have the connection pool. Okay? So bottom line is there is no single point of failure, whether it's catalog, whether it's shard tier or at the shard director level. Okay? Here comes the most important one. We talked about the deployment. We talked about the schema requirements. We talked about how we create a sharded schema and the duplicated tables, etc. The next step is for the applications to get to the right shard for a given key. So what we have done is we've enhanced few APIs, whether it's OCI, whether it's ODP.NET, whether it's UCP, right? And if you have third-party Tomcat, etc., or WebLogic, etc., you can still use it as long as you use UCP as a data source behind the scenes. So what I'm going to do in this example is I'm going to show you what are the API calls that you would do to build a sharding key and pass the sharding key to get to the right shard. So here are the calls, right? Create sharding key builder UCP is the call that I'm going to do. I'm going to build this key for Mary.Smith, the value of that particular sharding key. I'm going to build it. I'm going to check out a connection using the key that I just built, using the create connection builder. Right? From the connection pool perspective, I built it, and now I'm going to check out a connection using this key that I just built. Okay, these are the 2 things that you would do from your application to get to the right shard. Okay, so now let's walk through what happens when you check out a connection, etc. Okay. The 2 phases, but I'm going to talk about the pool initialization phase first, and then I'll talk about the runtime phase. But let's say the database, the shards are up and the pools are just initialized, right? So now the customer ID 123 is passed to the application server, the connection pool now got the key. Now it'll go to the shard director. And the shard director understands the shard topology map, looks up the map and knows that, hey, this particular key 123 is in shard 2. I'm going to redirect that connection so that from then onwards, this connection is made onto that particular shard. All transactions are made within the scope of that shard. Once the transactions are done, you check in the connection. Right? And this is the process that happens when pools are initialized on the very first connections to these shards. Right? So there is an important enhancement we have done. On the very first connection to this particular shard, connection pools are empowered to extract the topology information from this particular shard into their memory. What's the topology information? The information such as what are the chunks that reside on the shard, what are the ranges of sharding keys that are mapped to those chunks. That information, that metadata, right, is brought into the memory of the connection pool, the application server. And it does so on the very first connection to these shards. Over a period of time, the connection pools will have a memory structure which looks like this. Hey, what are the chunks in this sharded database? What are the ranges of sharding keys that are mapped to the chunks? And what are the shards that these chunks are residing on? Right? This array, this structure is in the memory of the connection pool. So once the pools are initialized, when a new connection request comes in, the connection pools know the topology structure. So it knows and it goes directly to the shard for a given key, completely bypassing the shard director. So at runtime, the connection pools go directly to the shards based on the key that you provide, completely bypassing the shard director. And that's how we are very fast and scalable. Right? So now you may wonder, what if I add new shards? How does the connection pools know? Or if I remove a shard, how does the connection pools know? That's when the shard directors play an important role again. Anytime there are structural changes, configuration changes that happen in the shard here, whether you relocated a chunk, whether you added a new shard, for those kind of structural changes or configuration changes, shard directors publish FAN notification, the fast application notification via the ONS channel, the Oracle notification service. Right? So that's how the connection pools update their memory structure with the new information, with the updated information from the shard directors. And this all happens in runtime, real time. Okay? So that's how they know, here is update topology. And let's say Mary got moved to another shard, they will automatically route you to that particular shard. Okay, so this is the fast and direct routing. To get the best scalability, this is what you want to do. You want to build a key and pass a key, go to the right shard, execute the transactions. You could have thousands of shards, millions of customers, and you could have petabytes of data across these shards. You still get linear scalability. Right? And I'll show you the benchmark results in a bit. So that's direct routing, right? Where you can use it for OLTP transactions. Now, for a reporting workload or for workloads that cannot pass a key, you would do what's called as proxy routing. This is for multi-shard queries, when you want to go across multiple shards to get your queries executed. So again, important thing is both with direct routing and with proxy routing, there is zero change to your SQL code. Your code is untouched. You take the same exact SQL and then you play it here, right? The reporting, in this example, the reporting query that I'm showing. So when you run this query, it has group bys and rollups, etc. You are going to the coordinator first, right? Which is the shard catalog. It acts as a proxy router. The coordinator parses the SQL and rewrites the queries so that the most of the processing is done at the shard level. Okay, so basically the shards become compute nodes in this example, right? And then once the queries are executed here, the data is brought back. The data is brought back to the coordinator, and if there's any ordering, rollups, etc., that need to happen on this data that's brought from the shards, it'll happen here one last time, and then it is sent to the application server. And the important thing is, we also support shard pruning. Like for example, in this example, it's a scatter gather because I don't have where clause. But let's say I have a where clause, where shard key in, or certain list of shard keys, etc. We know that, hey, these are the shard keys that we have to go after, and we know that what shards these keys are, and we only go to those shards, and we prune the rest. Right? Just like how you have partition pruning in the regular partitioning world, in the shard database world, you have shard pruning as well. Right? You don't always do scatter gather across all 1,000 shards. You only specifically surgically go to those shards that have these keys and finish your execution, and you get back. Right? So that's again an improvised method, and it all happens because we have optimizer here. Right? We have a distributed optimizer that does all these tricks. Okay. What else? So we covered direct routing, covered proxy routing. Now, there's another question that will come up for DMS. Right?
Actually, Nagesh, there's another question that just came up on the chat.
Sure, thanks.
For multi-shard queries, you previously mentioned duplicated tables. Does database resident code, like PL/SQL, also get automatically replicated?
Yes, yes. If you do have PL/SQL code that you want to be present on all these shards, you again go to the catalog, execute them there, and the shard directors will make sure that those are all automatically propagated and compiled on all the shards. Correct. Duplicated tables will be present on all the shards as well as part of the material as we refresh. Okay. So DMLs on sharded table. There are certain restrictions with respect to DMLs. I just want to call it out here. In this first release, the DML statements such as update this table, set column, this predicate where sharding key equals constant, right? This when I run this, it can only affect one and only one shard. I can't have a massive update that will spawn and run across multiple shards, right? So that's important restriction that we want to know. It's just one and only one shard. But that being said, in my transaction, I could have multiple single shard DMLs. In this example, in my transaction here, I could have an insert that affects only shard 1, or an update, in this example, affects shard 2, delete that can affect shard 3. I could have all these 3 in my transaction, and then I could commit it. Right? In this case, I'm making multiple single shard DMLs. What happens is the coordinator will act as will start a distributed transaction and will do two-phase commit, right, with all these 3 DMLs. Okay. All right. The lifecycle aspects, DBA can explicitly move a chunk from one shard to the other. If they believe that, hey, this particular chunk is very active and very busy in this shard and is thrashing this particular shard, maybe I'll take it to another shard that's not overloaded, or maybe to a powerful server. I could explicitly move a chunk from one shard to the other with simple gdsctl command. If a chunk becomes too big, I could even split a chunk in the middle, and then you can move half of the chunk to another shard. Right? You have those controls. When a new shard is added, chunks are automatically rebalanced, and we use traditional RMAN incremental backbend transportable table space technology to relocate the chunks, rebalance the chunk.
Okay. Nagesh, a question.
Yes.
To avoid shard spanning DML, then before I run, say, an update, can I get a list of what shards would be affected?
What shards will be affected? There is a way to find out what sharding keys are mapped to what shards. Yes, you could query that dictionary table to identify what shards will be affected. Yes. Right. That's one way. The other way is to go to the execution plan and then see that as well. Right? So we do have the execution plan that will define which shard it's going after. So when I add a shard, I talked about the RMAN incremental backbend transportable table space technology that are leveraged to rebalance, to move the chunks around. Anytime when you split a chunk, move a chunk, add a shard, remove a shard, I mentioned that the correction pools get notified via the ONS channel, Oracle Notification Service. So basically the application has 2 choices there. Hey, you can reconnect or access the data read-only fashion, right? And that's with Data Guard. But with Golden Gate, because you have multiple read-writable chunks, the moment you are in the state, you can always go to another copy and write it there. Okay? And because shards are regular Oracle databases, all the best practices for backing up and restoring, they all hold good, whether it's shards or the catalog. And if you want to patch all the shards, you can go to one location to the catalog and run opatch auto. And you can specify, do you want to run it in parallel fashion or in a rolling fashion? Okay. Like I said, EM also supports monitoring and management of sharded database along with the command line interface called JDSCTL. There is SQL developer integration as well. So you could create your sharded tables. You can build your schema using SQL developer. Okay. Last couple of slides, I want to touch upon the benchmark results. It's an interesting exercise that we have done to understand, what's the scalability aspects of a sharded database. What we did is we acquired few shards, 200 of them on the Oracle Cloud, the Oracle Bare Metal Cloud. We have 100 shards in availability domain 1 in Phoenix and 100 in the other availability domain, and we are using Active Data Guard as part of the default setting. Okay. And then each shard is very high powered. There are 36 cores, 5 gigs of RAM, etc. Right? Very high powered servers at the shard level. Our goal was to understand, as I add shards to this pool, am I going to linearly scale my application or not? That's one. And the second thing is, what's the availability, the extreme availability that I touted about, right? Am I seeing that? Are you exhibiting that or not? Okay. So what we did is we took the swing bench order entry application, we ported it to be shard-amenable, basically adjusted the schema to have the key to be there on the child and grandchild tables, and followed the design considerations that we touched upon in the earlier part of the stack. We basically did those considerations, applied it to the swing bench order entry application, and we started the sharded database, 0, 25, 50, and we added up to 200 shards. and we were able to scale the application transactions linearly, right? And this includes both read-write as well as read-only workload. Okay, the read-write we're working on the primaries, and read-only is working on the standbys. So now let's take a look at those numbers. The elastic scale up to 200 shards. We kept adding shards up to 200. As we kept adding the shards, we were able to linearly scale your transactions. That out of 11 million transactions we were able to execute per second, 4.5 were read-write, 4.5 million were read-write, and 6.5 were read-only that were running on the standby. So basically, all your shards, whether it's standby or primary, they're all participating in the production workload in this example. Okay? And this is no surprise to us, and this is no surprise to the current production customers who have seen similar behavior as well. As long as you get the right application, as long as you make those design considerations, you are you're going to see these kind of numbers, right? In this kind of scalability number, the linear scalability aspect. The other one is the high availability, the extreme availability, right? So now what we did is we intentionally shut down one shard out of this 100 data guard configurations, right? 100 primary, 100 standbys. We intentionally shut down one of the primaries. And what we observed is there was 100% availability for the 99% of the application, and that one shard that is brought down has undergone a 15-second failover time in the Oracle Cloud to its standby, right? And this is with 12.2. So you're talking about extreme availability from Oracle perspective, right? Your application is available for 99% of the application, but 99% of the users, it's just 1% of the users did undergo a failover or the blackout. Okay? And this is with data guard. Of course, if you use Golden Gate, even that's eliminated as well. So the last couple of slides in summary. What is sharding? Basically, what sharding it is best of NoSQL and best of Oracle. Right? NoSQLs were great. They brought in linear scalability using commodity servers, extreme availability, and automatic deployment, etc. And as you've seen with sharding as well, you do have automatic data distribution. You have built-in replication setup. You get linear scalability. And then, of course, more than this, it's the sharding methods. It's not just the consistent hash. We support that like most NoSQLs do. It's the list space, the range space, the composite, dedicating certain set of shards for different regions, and then the centralized management. And most importantly is a native SQL. You're not undergoing, adopting to a proprietary interface. It's the same SQL that you've been used to with enhanced syntax, right? You get all of that, but you're not sacrificing asset. You're not sacrificing consistency, right? You're not sacrificing your transactions. And then you get all your traditional strengths of an Oracle database, whether it's security, whether it's compression, whether it's a multimodality, relational, JSON, they're all supported by Sharded database. Okay, so you get the best of both worlds in this. So in summary, what we talked about is sharding. It's a platform for you to build a distributed scale-out database, right? What we leveraged is time-tested technologies that we always had and built this architecture. We had partitioning, we had distribution using replication technologies. We co-located related data, right? And we did routing with OracleNet listeners. They've been there forever. They have been beefed up for a distributed environment now. And then the lifecycle management, right? All the time-tested technologies we always had have been put together, and we built a great solution for a distributed environment. And the important thing is it's ideal for applications where the data access pattern is primarily via sharding key. Primarily via sharding key. That's when you get the best of a sharded database. If your database is always, if your application is always going to do, proxy routing workload, maybe that's not the right one for sharding, right? At least for this release. You're in this example, as long as the data access pattern is via sharding key, you get the best out of Oracle Sharded database. You get the scalability, you get the extreme availability, and then you get the global data distribution. Licensing, I talked about it, right? For on-prem, you need Enterprise Edition, plus one of the high availability options, either Activity Record or Golden Gate or RAC. It's included in it. And if you want to do it on the cloud, you need to have extreme performance. before I open up for Q&A, I just want to touch on this particular slide, which talks about how you can get various collateral. There is one for OT and Oracle Technology Network. There's a portal that we have for sharding. I would strongly encourage you to go there as well. Go to Oracle Sharding. I do write blogs in my blog site. Please go check it out. That's one other place to locate. And then do follow us on social media, both for Oracle Sharding as well as my profile as well. Okay. I'll stop here and then see if you have any questions, and then hopefully I'll be able to answer this time. Okay. Hopefully, most of your questions have been answered. If you still do have questions, do feel free to reach out to us. We will be glad to help you on that. As well as if you're planning to do a proof of concept, do include us. Do let me know. I'll make sure that you get the right help. And if you're stuck or anything, I can definitely steer you in the right direction. The important thing is, if you are doing POC, do check out this particular website, the Go to Oracle Sharding, which has all the collateral. Whether it's documentation, webcasts, cookbooks, which will walk you through, how do you go ahead and deploy sharded database? How do you create a sample sharded schema? How do you do routing? All those examples are nicely covered in the cookbooks that I placed in this particular OT and sharding portal. I strongly encourage you to take a look at that as well.